Hello, and thank you everyone for joining us. This is a live with Nassim. However, Nassim is going to be joining us in about an hour. He's wrapped up in some physics and engineering some free energy devices and over Unity energy propulsion. So he's got some important work that he's focused on right now, but he's going to be joining us, and we're going to have that awesome opportunity to get to ask him questions and kind of explore his vast reservoir of knowledge and get to see the universe from his unique perspective that really, I think, gives us just some wonderful insight into better understanding the universe and our place within it. We also have with us Inez, um, part of the Residence Academy faculty. So me and Inez will be taking some questions in the interim. So if you can feel free to post your questions in the Q&A section. You can go ahead and post your questions for Nassim, he'll be on. And as well, if you have any questions for me and Inez, will be happy to open up a discussion on anything you want to explore. A couple of things. So on the for those joining us via Zoom on the Zoom webinar, on the chat, if you can change your settings to all panelists and attendees. So the default is all panelists, and so when you enter in a comment saying hi, or whatever it might be, under the default, it only goes to us, the panelists. But if you can change it to all panelists and attendees, everybody can see the dialogue there. And as I said, please enter your questions in the Q&A section. And the Q&A, it has a voting function on it so that you can give a question that you see. If you like it, you can give it a thumbs up, and that will bring the question to the top of the list. And it also helps us to field what questions are people are most wanting to explore and discuss in this particular session. So with that, do you want to give any update on what you've been up to, Inez, or say hello?
Yeah, sure. Hi, William. Hi, everyone. Okay, so first of all, as I guess most of you are already aware, there's Model 7 coming out. So that's one thing that's getting already finished. It's been launched very soon, like next month, very probably first, second week. So that's like about the most exciting news I have for the moment. Also starting Module 8, which is basically the paper that has been working Nassim and Olivier since a year or a little bit more of that, which is amazing that you, William, and I had the opportunity to have a brief downloading at first, which was amazing. Then also as well, I'm about to publish an article. It's a paper about the electron review. It's a review of an electron, of the models, semi-classical models of the electron. So that's also finished already. I'm about just finishing the last details. And this is very exciting for me because this is something that is really connected to what it's going to be launched in Model 8. It's really connected to the paper that's coming out soon as well. And it's very gratifying for me also as well, because of that subject. I have met many physicists in the mainstream approach, let's say, that are really, really, how would I say that? Unhappy with the state of physics at the moment. So for me, it was quite a surprise to know that we were not alone, that it is a big community of people that are kind of not convinced of the Copenhagen interpretation and all of that weirdness about quantum physics. And so these are approaches to the electron that are very close to the holographic solution. So it was amazing for me to realize that there were many people thinking on the same subject, approaching it in a very similar perspective, although they didn't totally let's say, since the holographic solution is something that is not completely understood and taken by the mainstream approach, then you lose basically the main part of the model. So all these models get very close, but because they miss that small link, then it gets almost there, but not exactly there. So at the end, it was beautiful for me to collect all these visions in a very, let's say, organic way, because they thrive from one model to the other, and ending with the holographic solution for the electron, which is Amir Malbaker's and Nassim Haramein work. And that was amazing. So yeah, and I even got to develop it a little bit further, these calculations. And so it's amazing. So on that side, well, I'm very happy. Electron paper, Model 7, Model 8, and and Shintergy experiments as well here in Mexico. So so yeah, I'm busy.
Yeah. For those who might not know, the Shintergy experiments are a series of experiments that Inez and her research team have been doing, looking at the effects of consciousness on physical systems. So a way to measure conscious activity at a distance, in an objective measurement way. So it's influence on physical systems. In this case, light emission by a laser and detection or reception of that photo emission. They have a very experienced meditator, somebody who's got 20 years of practice in this specialized, I believe it's a Do-Chin Buddhist type meditation. And he's able to go into a meditative state, and you can see a change in the photon flux, the reception of photons by the detector.
Yeah, exactly that. It is amazing. His name is Jose Luis Bueno. He's the leader of this part of the research. The Shintergy project is his project because that's the training he developed on his own, because of the training he had already, because with all this suction tradition and the monks. So it's called linaje in Spanish. I don't know how that word would be in English. Like the tradition of all the monks that follow the same path and that reincarnate and follow the same teaching. So that was fascinating. And so yeah, we have very interesting results, some of which we partially reproduced in Taurus Tech as well. And so well, that's also part of many of the things that we're working on.
Yeah. So those were some interesting results here. So we have a very isolated detection setup here. So we've got one of the most robust Faraday cages that could be constructed. It's our advanced physics isolation chamber. So Faraday cage, it blocks out all ambient electromagnetic fields.
Yeah.
And we have a extremely precise photo detector. It's a photo multiplier tube, so it can detect one photon every millisecond, or even at shorter time intervals. So an extremely sensitive photo detector system, and a stabilized light source. It's a laser that emits a very specific amount of photons per unit time. And we did some of these experiments with Jose Luis, and it was very interesting. Some of the results we saw. One of the things that was very interesting to me, even from a biology perspective, is that oftentimes having the person in the room would increase the photon count on the photo detector. So that's a very interesting effect that, kind of raising questions. Is this related to biophoton emission, photons being emitted by the body, or the energetic aspects of the body increasing electromagnetic field activity around the photodetector? Some very interesting results with the research we did.
Yeah, that was very interesting. And it also raises the question, because in principle, the detector shouldn't detect, the emitter it shouldn't detect photons that are thermal photons, because it's not in degree of detection. So yeah, we still have many things to further explore. For the time being, this is part of the project. And so yeah, so basically very exciting. And also we are trying to figure out the biology part of it. I mean, like, let's say that would be like with you and Nassim and all the group together, like to figure out how we could ensemble this experiments with the model, the theoretical model of the paper that's about to come, and also with the biological part as well, which will be very interesting.
And so in the electron review paper that you just did, you were looking at the phenomenon of Zwitter-Bewegung.
Yes, yes, Zwitter-Bewegung. You know, it's really amazing because, I mean, me coming from let's say the standard approach and at the atomic and molecular level, Zwitter-Bewegung was something that I was not aware of. When I first started working for this review, I was like, you know, when you start, you just look around and see how many things you can explore. This Zwitter-Bewegung captured my attention since the beginning because I said, oh, wait a minute. Zwitter-Bewegung, for the people, because that's a German word, means trembling along the way, electron motion. And this is something that Dirac, well, not Dirac derived the equations for the electron in the frame of the relativity scheme. But then Schrödinger, when he was analyzing the solutions for this equation, he found that there was this oscillating at the speed of light phenomena in the electron. And so this created a huge, you know, what's this? It's not possible because the electron has a mass, and so it cannot be moving at this speed, because then what happens with this mass, you know, and there was all this discussion going on. So the solution that they found was to say that the Zwitter-Bewegung was a relativistic effect that happened in the relativistic regime, meaning by that at the speeds which are approximately the speed of light, and that it was due to the interference between the positive and negative states of the Dirac sea. So that's the way, you know, this positron electron dynamics, it's something that they use very often to say, okay, we're not exactly violating any law. We're not, because it's happening so fast that you would seemingly not violate any conservation law. So that was the main explanation for it. But you know, because we work in the holographic solution and we have a classical solution for it, this was not like, when I saw this interpretation, I said, no, this is when I found these other authors that were claiming as well as me that this could not be, I mean, because they use Zwitter-Bewegung to explain the spin of the electron. But as you know, spin is only accounted for in the quantum regime. It's supposed to be something that's only happening. It's not like a classical effect. It's not something that you would say this electron is really spinning. And this is a huge debate because under these approaches that I have studied and that we have developed ourselves, it is a real precession of the electron. It is a real movement. Yeah. And so many people have been working on it. Richard Gauthier, Jean-Louis Van Belle, I mean, David Hestenes at Arizona State University. And so all these people, we have like created this kind of group of discussion team where, well, all of this is being debated. And so, yeah, Oliver Conza, Giorgio Vassallo. I mean, it's a beautiful, beautiful group of people, Alexander Burinsky, and they all bring something different to the puzzle. So it's amazing. And the Zwitter-Bewegung, so it seems that, yeah, it is a real phenomena, and it would explain this, of course, the spin of the electron. So yeah, and it's really related to the solution that to a different perspective of the holographic solution. You will see when the paper comes out that the interpretation that we have given to the holographic solution is it's on the thermodynamics perspective, information theory perspective, is also very related to a different perspective, which connects all scales. And well, that is eventually that spin, but why is it the spin? So it's beautiful. Zwitter-Bewegung.
It's kind of interesting that whenever the mainstream physicists kind of run into a problem. Oftentimes the solution is to invoke the quantum vacuum. So it's like Zwitter-Weyergang is interaction with the positrons and electrons of the direct C, even with the Higgs mechanism, which only accounts for 2% of the mass of the nucleons. The other 98% of the mass are gluons and quarks and anti-quarks fluctuating in the quantum vacuum, and even the electric charge of the electron. So the bare electric charge of the electron under the standard model is infinite. It has an infinite electric charge. And to solve that, you just envelop it in these layers and layers of electron-positron vacuum pairs of the quantum vacuum and shield out all of that infinity except for -1 unit. So yeah, it's very interesting that oftentimes the quantum vacuum comes into the rescue, but it just seems to me like maybe we should start with the quantum vacuum and work out, and not just pull it in whenever there's an anomalous situation that can't be explained using the standard model.
Yeah, exactly. And yeah, that's exactly that. And also the fact that how come I never heard of that before? Okay, I was not working at that regime. I usually don't work in the relativistic regime, but nevertheless, zero Weyergang, that was the first time, something so important. That was the first time I heard that word, like I mean, I just couldn't believe it. What they do with this, I mean, so we have also this tendency, to just like look on the other direction when there's something we don't totally understand. And well, okay, I understand that there's a lot of pressure also as well on the mainstream physics, and you have to, keep on with publications and articles. So maybe you don't have the time to really think about things. This is like the privilege that only a few physicists can have, because most of the time you're giving courses, theses, and PhDs, and so we don't have the time really to really think it through like deeply. So only for the very privileged ones that could even have 10 years with no publications because they are considered, like geniuses. These are the ones that are allowed to have that. So that's a feedback loop, which is really marginalizes many of the physicists in the medium, because then you get like marginalized. But well, anyway, so that was the thing. So yeah, very interesting, and I just can't wait for the paper to be out, so all of these can be finally, solved. And when Nassim comes in, he will probably talk a lot about it. And well, yeah. So that's
definitely looking forward to seeing that paper. Do you have any idea when that might get released?
It was supposed to be like in 2 months, but I don't know. It's like, it's the thing is, each time you advance a little further, you see the connections going in many other directions. And so you say, Jesus Christ, this is like a never ending fractal. So that's exactly what's happening. Oh, And so the further you go, the less resistance you will have to be accepted. If it's explaining this and that, and also that, and then it goes further to explain that as well, and backwards and forwards and in any direction, up and down in any scale, then so it's like I can imagine it's like, wow. Well, yeah, it's not easy to deal with that kind of information. So yeah, that would be the thing. And it's curiously enough, there's a question that was related to what we were just discussing, so maybe I could address it right away. Because this is Richard Harenberg.
Yeah, I was going to ask you to take that question. Yeah, because I was just looking, in the quantum gravity and the holographic mass paper, it says Frank Wilczek posed this question. We see that the question it poses is not why is gravity so feeble, but why is the proton's mass so small? For in natural Planck units, the strength of gravity simply is what it is, a primary quantity, while the proton's mass is this tiny number. So Richard Herrenberg is asking, how can I explain that the Planck mass is much greater than the proton mass? Can I use a photon with the Planck radius and frequency to explain it?
Yeah. Yeah, you could do that. But the thing is, because we have to keep in mind, and this is something directly related with the hierarchy problem that happens in physics. So the hierarchy problem is exactly this. How can we have a mass, such a big mass in such a small particle? Because, you know, if we dealt with the Planck as it was a particle, which is what we do in the holographic model, that's the main difference. We take the Planck spherical unit, it is a particle, a real particle of the space. So meanwhile, it is taken as a unit. In mainstream physics, Planck, it's the Planck unit. It's like the smallest distance you could measure. And so, which is pertinent to the size of our universe. So that's a main difference. So here the thing is that when you see the solution for the electron mass, which is a beautiful model, it makes you understand that what we're talking about is angular velocity relationships between the Planck, the proton, and the electron. So at the core, you have the singularity, which is at the size of the size of the Planck scale, and at the size you have you have this vorticity, right? And so, as you know, and this is some work that Alexander Borinsky has proposed as well, spin is also curving space-time. It is the main ingredient for the curvature of space-time. So even though you think that you have particles, subatomic particles that are very high, very light in mass, what's happening in reality is that they have a very high spin, a very huge spin. So that spin is also curving space-time. This is another way of looking at it. So when you have so you know the proton is composed of Plancks, right? Of these Plancks. And so these Plancks are, and they're coherently spinning, like in this vorticity. So you have at the Planck scale, you have this vorticity, which is at its maximum, right? And it starts to decay as long as you move away from this center of the vorticity, like the center of the hurricane. So that's what's happening. If you realize that the mass is related to this strength of the vorticity, let's put it that way, as when you're moving away from it, your mass is decreasing because the speed is decreasing as well. And this is seen in the other sense as the mass dilation, which is taking this the other way around. In relativity, you usually say it backwards. You say, as you approach the speed of light, the mass increases, right? This is another way of saying that. So you could approach to this speed, or you can go away from this speed. If you go away from this speed, it is not a mass dilation, but a mass contraction. It's getting heavier. And if you go lighter, and if you go mass dilation, the term mass dilation, you have to be very careful if you're referring to what direction are you heading to, if it's going to the speed of light or going away from the speed of light. So if you go to the speed of light, you're increasing your mass, the vorticity. Okay, remember that the gravity is also a measure of the vorticity. It is the measure of the vorticity, and the vorticity is also the spin. So when these particles, exactly what they are is that they are particular conditions in this dynamics of the spin of the vacuum. So they're happening at particular ratios. So the proton is happening in a particular ratio, the electron is happening in a further particular ratio with respect to the proton. And so this is the natural way of understanding the hierarchy problem. The hierarchy problem is just following that line of angular velocity relationships. So this would be like the most comprehensible way of understanding this issue of the difference between masses and size and all of that. So of course, as you spin faster, the mass is compacted further. This is another way of so it's denser, so it's more massive, let's say. So that's the thing. That's the way I would approach this problem. Of course, when the Model 7 comes out, you will see this in detail, how this velocity relationship happens, how the electron is explained under this perspective, and you will also see why the Planck is also concerned. why its mass is higher, and why let's say in the hierarchy problem the mass of the proton with respect to electron is also explained, and the mass of the electron with respect to the proton. So you will see that there's a hierarchy which is very natural, which is not understandable from the standard quantum mechanical approach and relativistic approach, but from the perspective of the holographic model, it comes naturally from the model.
And can I use a photon with a Planck radius and frequency to explain it? It really does come down to the spin in that relativistic mass dilation.
Yes.
Yeah.
Exactly. So usually when the person is in the audience, we kind of pop them out for the question. So, but I don't know if this is something that Jamie would have to do. So I don't know if Richard was present, but in any way, because sometimes they have access and they ask the question directly. So if they have any further question, we would address it like that. But in this case, I don't know. So let's maybe move further to another question.
Yeah, I don't know if we can bring people on during this session. Maybe if Jamie does have that capability, he can start bringing the folks on when we answer their questions.
I might be able to. Whose question is it?
This was from Richard Herrenberg.
Okay, one sec. Okay, Richard, if you want to go with your video, you can, or you can keep your video off, but you should be able to talk. You're a panelist.
You'll need to unmute yourself, Richard.
There he is. Hey, Richard.
Great.
Hi.
Great answer. Now, I'll give you the background to this question. 2 weeks ago, Im asked William a similar question about the 10 to the 60th Plancks and a proton, and Im thought that he understood the answer about density, how to go from the Planck to the proton. So last week I asked him what he understood, and he wasn't able to explain it very well. So he says, we'll have to ask William. And then the group said, well, I should ask Nassim next week. So I tried to figure out an easy way, and I tried to figure the answer myself. So here's the answer that I came up with. And you can tell me whether this makes sense. I tried to find a simple answer. And it starts with light and the Planck frequency, which is the highest possible frequency. And the Planck particle is vibrating at this enormous frequency, which is an enormous amount of energy. And in fact, if you convert that energy to mass, I think it's like 750 kilograms or some huge number. And that's another strange question. How could that be?
The Planck energy, if you convert it to mass, it's 10 to the -5 grams.
Yeah.
Oh, well, here's, okay. What I did is I took the Planck frequency and used E equals HF. Okay. And, so the general idea that was amazing to me was, how can it be that as the photon gets larger and larger, it has less energy. The wavelength gets longer, it has less energy, E equals HF. And when it gets shorter, like a Planck, it has this enormous amount of energy. And so I was able to calculate that for a proton and so on. And so it made sense that yes, the photon energy for a proton, if you considered a proton as a photon of the proton radius being the wavelength of the photon, you can explain, well, yes, the mass would go down considerably because the energy goes down. So then I said, well, I wonder if that same ratio works for mass, that the mass would decrease the same way as the photon energy decreases. And that seems to be the case. That sort of explained it to me.
Yeah, it is. It is another way of looking at it.
And I'm sure I took some shortcuts in trying to explain that. But it intuitively, it makes it much easier to understand for me. Oh, now I'll give you one more part of the story. I came to this idea because I was trying to figure out what the vacuum looked like. And it seemed like it couldn't be filled with Plancks side to side, because then that would be one huge proton for the whole universe. So that I couldn't explain that. I said, well, the universe is really filled with light. The vacuum is really filled with light. And that light is similar to the Planck photon at the Planck frequency. It's gamma ray light, extremely high energy. And then I said, well, it probably is filled with photons of multiples of the Planck photon. So remember, that's the smallest possible photon. So there's probably light of 2 Planck lengths, radius of 2 Planck lengths, and 3 Planck lengths, and 4 Planck lengths, which is frequency of 1/2, 1/3, 1/4, and so on. So that the vacuum must be filled with all these little photons of all different sizes. And that seemed to make sense to me. And then Inez was talking about how the virtual particle idea is used. And at one time I said, well, a photon is an electron, or an electron is a photon. And people say that, yes, a photon converts itself into an electron and a positron. The photon only lives for one little flash, let's say 1 Planck second. And then that flash creates an electron and a proton, but they only exist for maybe a few Planck seconds, but they have mass, interestingly. So we went from no mass, or from the Planck mass, well, no, let's not confuse Planck. We went from a photon with no mass, and then all of a sudden we had some mass, electron and a positron, and then we go back, they combine, and there's another photon. And actually they say it's 2 photons that produce an electron and a positron, and then that reaction produces 2 photons again. So that helped give me the idea that the vacuum was filled with photons. And then one other thought was that the Planck and the proton are black holes. So the question would be, how come we can't see all this light, even though it's in a different part of the spectrum where you can't see it, it's gamma rays, but you would certainly sense it. And the answer seems to be, first of all, it's contained within the black holes, doesn't get out. And second of all, as this little reaction goes from the short flash of the photon to an electron and a positron, and then back to a photon again, that those photons are immediately absorbed by the electron positron. There's no photons to escape for us to see.
Yes.
And that's why we don't see them. So those are some of my ideas, and I'm looking for where I made mistakes. and but it's been a very interesting thought experiment to try to figure this out. Now I'll let you talk. Sorry for talking so much.
No, on the contrary, it was amazing. I'm curious about your background. You have a very deep intuition of it.
Oh, well, that's an interesting story. Now, I'll give you the real short story. When I went to college, I ended up going to a very small college. This one is in the 1960s, and we had just had Sputnik and all that, so there was a big push for science. And the college I went to had only 1,000 students. But because of the push for science, they had 4 PhD physics professors. And this was a liberal arts college, so this was very unusual. There weren't many students taking physics. There were 4. Only 4 physics majors, and I was one. And I didn't realize that I should have gotten a PhD for my undergraduate degree. I didn't realize how good it was until later when I went to other schools. And then finally some advisor said, well, you should have at least gone for a master's or a PhD program instead of getting more background in other areas. So anyway, that's the quick story. Now,
amazing.
I've been very fortunate to get a tremendous education with my career in all kinds of different areas, in engineering, electrical engineering, communications, and physics. So that's the quick story.
Amazing. It's amazing because it's most of what you said, it's correct. You can think about this Planck spherical units as electromagnetic fluctuations, which is basically photons. No, so the thing is that when they organize coherently, that's when mass happens. Okay, so that's the thing. Also, as well, when you have creation and annihilation of photons, the dynamics of the electron positron and the photons is, as you say, too fast for it to happen, to be observed from our perspective, from our time scale. So that's as well correct. Basically, all of what you said was correct. What would I kept something, but because I asked you this other question, now I lost it, what I had on my mind.
I would add one thing to it. So when you were trying to imagine the ordering of the Planck spherical units in space, I think that you came to a valid conclusion there, that if they were all ordered, say how we imagine them in the proton, then everything would be a proton. One of the key pieces to this, though, that you might not have yet come across is that so those Planck spherical units, we have to think of it as a Planck plasma. And so what that means is that, so indeed, the ultimate source of these Planck spherical units are that they are quantum harmonic electromagnetic oscillators. Now, via certain geometries of space-time, these photons can get a dipole moment, just like the electron, just like the proton. So the Planck spherical units, these PSUs, they have a dipole moment. Now, in most of the circumstance, the alignment of those dipole moments of this Planck plasma is, I'm going to say, chaotic, and that there is, it's actually symmetrical. They have a symmetrical orientation of the dipole moments, and what that means is that they're all pointing in every possible direction.
So they cancel out.
Yeah, so it sums to zero essentially. That is the orientation. That's the ordering of the Planck plasma that comprises most of space. Now, in particle physics, the statistics for that is called a Fermi gas, a Fermi state. Now, there's the Fermi statistics, but then there's the Bose-Einstein statistics, the Bose statistics. So what you have is that you can have symmetry breaking, where that symmetrical orientation of all those BSUs can be broken, and you get an asymmetry, which basically means that all those dipole moments align. Now, when that happens, you have this transition, a phase transition from a Fermi gas to a Bose state, a Bose-Einstein condensate. That transition, that is what we call matter. And that's where you get mass. Those are the particles in this Planck plasma sea of energy. It's where you have a Bose-Einstein condensate. And if you go out to the boundary, what you can think of like as the surface horizon of the black hole, this Bose-Einstein condensate, you have this Fermi-Bose mixture. So you're starting to get, you've got a transition point at this boundary condition at the surface horizon. And that's where you see things like mass and the electromagnetic field. So that's where you see actual like light that's there, right? Because it's all light. How come we don't see light everywhere? It's at those boundary conditions. And that's also, where you get mass and electromagnetism.
Thank you. That did remind me that, yes, this virtual particle thing with the flash of the Planck photon and the electron and positron is a plasma. So in theory, the vacuum would be glowing like a plasma, except at gamma ray frequencies. And I have not done the calculations to figure out what all this implies.
You can see the glow of the vacuum. It's called a Unruh radiation. Yeah. So you basically, you have to create an event horizon to see the glow of the quantum vacuum. And there's two ways to do that in relativity. If you approach relativistic speeds, you create a event horizon behind you. And so you'll actually see photons emitting from the vacuum ahead of you. And then there's also Unruh Hawking radiation around a black hole. So you can actually see the photons or light emission that is occurring in the vacuum under certain states.
Great. Well, I figured some ought to leak out. So that would be an interesting question. Yes. Now, you asked my education. My secret is that I go to Google and I put in the words like quantum vacuum or something like that. And then there's always millions of answers. And I look at the pictures. And I look through the pictures and pick out the ones that seem to make sense to me and maybe read the article that goes with the pictures. And then lately I discovered that there are YouTube videos, some of which are pretty good, that try to explain some of these things. And so I take a look at those, and what I've learned is really a compilation of what I've learned from the Resonance Science Academy and, and Google. And certainly some places have been better references than others. And those have become my favorites. So that's the quick story.
Awesome. Amazing. Amazing. Thank you, Richard, for your question.
Well, thank you for your answers.
Great question. And you know, it kind of is along the lines of another one here from Simon K3. We might have already just addressed this entire question, but it was asked, are we made of protons or Plancks? Or are they considered the same for you, i.e. Plancks as photons or PSUs? If so, how would you distinguish this scaling for the 99.9999% space light that we as human beings truly are?
Really quick, who was that again, William?
That was Simon K3.
Okay, thanks.
They might want to add to that question in light of what we just discussed, kind of, you know, elucidating the difference between the Planck spherical unit and the proton, but you know how the proton is Planck spherical units, just in a different state, basically in a quantum coherent state, a Bose-Einstein condensate. And so
again,
Simon K3, Simon K3.
Huh, I'm not seeing.
Oh,
They
maybe
may not. They may not be here still.
They might have got their answer and left.
Yeah, right.
But you know, I would just say I don't know what you will might want to add to this, Inez, but just that fundamentally everything is made of this Planck plasma, the Planck spherical units, and the geometry of space-time and how that energy resonance and harmonics creates these wave patterns in that field. So, you know, ultimately, fundamentally, we're made of that Planck substructure of space, but that's what makes protons. And so we're also made of the protons that are made of that substructure of space.
Yeah.
You guys want to choose another one before Nassim comes in?
Sure. Have you been able to see any questions you might want to field, Inez?
I was just going around them, so
Thank you, Richard. We're gonna move along to the next folks. Appreciate your extensive knowledge.
Yeah, it was amazing. Wow. Okay. Dun, dun, dun.
Yeah, because you know, I see some questions like, what do you think is the most important step for us to attain free energy vehicles and devices? And certainly, I have some opinions on this, but it's
come on, really, go ahead. I'll follow your lead.
It's nowhere near the insight that we're going to get from Nassim.
But we can start. We can start.
Yeah, so we'll start. Maybe he can come in and correct us where
that would be awesome. Yeah, that's great. Let's go ahead. Yeah.
Yeah. So kind of somewhat obviously, but still, I think it needs to be stated clearly. The first step is understanding that we live in a sea of energy. The universe is permeated by a field of energy. And although to our naked eyes and even to many of our measurement apparatus that we've been able to construct thus far, although it might appear to those rather rudimentary instruments that space has a very low energy level, we know from more sophisticated measurements of the structure and mechanics of the universe that there is an extremely high energy density. to this sea of energy, this energy that permeates all things. And, from a kind of theoretical perspective, I can't believe you would come to any other conclusion when you look around and you see quasars, galaxies, stars, planets, living things. There's obviously a lot of energy in the system. That energy came from somewhere. And so understanding that not only is there an extremely high energy density to what we perceive as the most empty unit of space, but even more than that, that this energy is connected in a multifractal, holofractal, multiverse system. So there is nearly limitless energy to draw from. So that is the first realization of free energy. The idea that energy in the universe truly is limitless. It's absolutely abundant. And the idea that you need to perhaps disrupt a system to obtain energy isn't necessarily the case. In fact, in most instances, the way that the universe obtains and utilizes this vast amount of free energy is in a process of creation that increases the overall coherence, harmony, the synergistic organization of the universe. And that's really the technology that we're looking to achieve. It's really fundamentally, how does the universe obtain energy? That's how we want to do it. And that's, I believe, how it's going to be accomplished is really replicating some of the natural systems that already have this harmonic energy exchange with that vacuum energy, that energy that permeates all of space. And so that's kind of like a real general perspective on it. That's kind of setting up the framework. We need that framework to be adopted by more than just a few scientists. I mean, not only is that going to get science out of a lot of the challenges it's gotten itself into, but it's going to enable the next generation of technology, which is things like gravitational control. So the ability to engineer the structure of space in order to control gravitational fields. That's going to be a huge part of getting this kind of free energy and novel propulsion mechanisms. And so more specifically, I think that one of the first steps in doing that is there has to be the creation of a boundary condition in space. So one of the issues is you have this nearly infinite energy density. Let's just say it's an extremely high energy density in free space. But because it's in this Fermi state, this symmetrical state, it's not available to do work, mostly, because it all evens out. It's kind of like thermodynamic equilibrium. So what you need is a way to introduce thermal disequilibrium, a boundary condition that pushes it out of that symmetry, so a symmetry breaking, asymmetry. And in that way, you can use it to do work. But the mechanism in which you use to create that boundary condition, that asymmetry, it has to be established in such a way that the energy that is drawn, a certain amount of it feeds back to sustain the boundary condition. And that's a free energy device. One of the simplest ways to do this, the way that nature does it, is via spin. So you've got this Planck plasma that's a Fermi state with all the PSU dipole moments pointing every which way in this overall symmetrical net zero configuration, if the moment that you introduce spin, this is actually like a fluid dynamic property. It's a rheological property. The moment you introduce spin, those dipole moments will begin to align, and that's the symmetry breaking. That is the introduction of coherence, and shifting to a Bose state, Bose-Einstein condensate. That produces the boundary condition, and now you can begin to extract energy from the vacuum. And just in time, we have Nassim here to clarify or resolve all the things I just said.
That sounded really good.
It was okay.
I was like, wow, who's that scientist?
I've been listening to what you've been saying, so I'm
Nice. Right on. Sorry to everyone for not being available in the last few weeks, and coming on late today. It's been epic time. Please be patient with me, everybody. I'm doing my best to keep up with everything, and actually, it will be worth it. I swear it'll be worth it. It's a little suffering right now, but when I'm done with what I'm doing, then I think you're all gonna really like what comes out of it. So I'm pretty excited. So you guys been answering questions?
Yeah, we had a couple of really good questions we started out with. There was a question on the hierarchy problem, and Nez was able to I think explain that in depth. Just so why is it that the PSU mass is 10 to the negative 5 grams and the proton mass is what is it, 10 to the negative 23 grams? So there's this huge disparity between those two masses.
Right.
So we were able to explain that some, and then also how it is that the configuration of the PSUs can give rise to empty space in one hand, but then also structured mass and the proton in another state. So kind of introducing the idea that Planck plasma.
Right. Great.
And the part of fermionic versus bosonic and how it is happening in the space transition between the two and all of that was amazing. It was amazing.
Right on. Awesome.
Yeah.
That's really important. And what you guys are discussing right now is stuff that most physicists that are doing advanced research in unification or is thinking about advanced concepts of physics, like fundamental concepts of physics, not just like the stuff on top, but like people that are working on understanding entropy, understanding parity and symmetry in physics and all this. These are the things that they struggle with. And what you guys are talking about is the resolution of all of these problems, in a really simple, beautiful, fluid dynamics, mechanical way that is fractal in nature and so on. I mean, it's remarkable. And that this disparity between the mass of the Planck and the mass of the proton, the mass of the proton, this hierarchy problem, because I mean, clearly, if the Plancks had a 10 to the minus 5 grams mass, if they have a 10 to the minus 5 grams mass, why is it we don't see the gravitational effect of that? I mean, it's like the universe should shrink into like the size of a basketball, right? So, because there's a lot of those little guys, so that there's a lot of mass, and that's that. If you were to look at the base of that issue, the base of that issue is the distinction between between gravitational mass and inertial mass, and the relationship of the two. You could think of it in a different way. You could think of it, the difference between rest mass and black hole mass, right? The Schwarzschild condition of a system. So because the Planck pixel is described only theoretically, meaning it emerges from, you know, quantum theory, from the fundamental physics that we observe, but we don't measure its mass directly, meaning we know its mass is that because it's, you know, everywhere in our equation, so we know it gives the right answer in all this. But if we would measure, so we could think of the Planck mass as the black hole mass of that object, right? Where the black hole mass of a proton would be 10 to the 14, right? So it'd be, you know, a huge mass, right? So it would be, there wouldn't be a hierarchy problem, right? It would, the proton being much, much larger than the Planck would have a much, much larger mass, right? That's not the case. Why? Is because there is screening. You can think of it as Poisson screening. And this is a concept that's already in quantum theory, but it's not understood well, meaning they use it, right, with the Klein-Gordon equation and all this. But basically, you know, that it's not all the energy of a system. When we say mass, we can convert to energy, right? It's not all the energy of the system that's expressed on its horizon. Most of it is screened from the horizon, most of it. So you can think of it like you have a coherent crystal, right? And because it's spinning, right? But the interface between that crystal that's spinning and the exterior is Fermi. So it's messy. It's you know, it's got a lot of random fluctuation of like the little Plancks going everywhere, and that screens the energy that's present. So you get a black hole in the middle, but you don't know, right? Because it's screened. And so the measurement, the gravitational effect you're measuring is the screened mass, right? And so that there's and this is what's missing in quantum theory. This might sound really crazy, especially if you're a physicist. You might not be able to follow what I'm telling you. You will when we publish this next paper, because it's crystal clear. It gives all the right answers, all the right constants. I mean, all the constants, all the conservation law becomes unified, you know, all the scales. I mean, it's outrageous. The Gibbs free energy, like in terms of thermodynamics, all comes out, right? So basically, the Schrodinger's equation, the Heisenberg equation, everything. But basically, the reason we've been missing this part is because we've never actually put the source of energy at the center of the system. The source is what we think of as the Schwarzschild solution in terms of energy to that system. That is the black hole nature, the fractal nature of the system. That's where it gets its energy. And we tried to go around the problem in quantum theory where we said, well, it's spinning, but it's not really spinning, because if it was, it would be radiating all its energy and it would crash and it wouldn't, right? Well, when you put the source in, you can stop playing all these games and trying to go around the problem. And all of a sudden, you know, all of the mechanics of it all works out. You realize, oh, there's a source of energy that's really, really high energy in the system. And I'm only measuring what's being screened, and that is the holographic mass solution. That is, the volume energy is huge, and it's screened by what's on the surface, and what you measure on the outside then is only the residual that's able to escape. And out of it, when you start thinking about it this way, then you get all the forces and all this comes out as well, because the screening, it gives you the right curves to describe, the loss of energy of the strong force and all this stuff. So this is, yeah, I'm really giving you a lot of like preemptive stuff from the paper. But let's just say that in the next few months, it will all get clarified. In words, what I just said is correct based on these equations that we just finished. And it's beautiful. All of a sudden, it just comes together and it's really, really beautiful. All the way down to like figuring out the scattering index of photons, and so on. I mean, it's just remarkable, and it's really amazing, because all of a sudden you realize, wow, we have a source of energy that's incredibly strong, and we know it's there. It's just all confused in the standard model, right? Like, for instance, they can't figure out the spin problem, they call it. They can't figure out the mass problem. I mean, they can't, because they're missing the fundamental. Like, for instance, the quarks and the Higgs mechanism only makes up like 1 to 4% on the max of the mass of the proton. The rest they have to extract from the strong force, right? From the energy of the force. But then they don't tell you where the force came from. This is one of the confusion that was happening when I published my first papers on this, called the Schwarzschild proton. Like, most physicists don't even don't realize that the mass of the proton is not present in terms of mass. It's present in terms of energy of the force, right? Which has no source in their models, right? Like, it's just magical. And so, they call it the spin crisis and so on, but it all really comes together when you put the source in. And all of a sudden, and we have the equations for the source. It just happens that they're cosmological equation, the Schwarzschild solution, right? The black hole solutions, right? The curvature of space-time. And usually those are not applied at the quantum level. Just like quantum equations are usually not applied at the cosmological level until they start to apply quantum information equation on, like, quantum cosmology on black holes, and then they got the holographic solution, or the holographic principle, right, which was their approach, and start finding, oh wow, it applies. Before that, I remember I used to be laughed at in physics conference when I would say that quantum effects are not considered at the cosmological level, and they would look at me like, of course, there's no quantum effect at the cosmological level. It's a different scale. And it's like, well, but big things are made out of small things. So, like, so yeah, but it's all coming together now. It's starting to make amazing. I mean, it's remarkable.
It's no wonder there was no solution to quantum gravity, no unification.
Of course.
If you're not considering the equations you're applying at the cosmological scale, at the quantum scale, or vice versa, how are you ever going to unify?
Right. exactly.
Yeah.
There's no way you're gonna do it. And then if you have a confining force at the quantum scale and you've invented a whole formalism to account for it, right? And that formalism is not compatible with cosmological equation for confinement, which is gravity, then of course it's not going to work out. But we found how to make it work out. And basically you just got to add the source. And then when you add the source, then then it makes sense. But then you have to scrap a good portion of quantum theory. I mean, you don't really scrap it. You can demonstrate that it links to it. You can talk about it that way, but it's way more complex than it needs to be. You can talk about it in more simple terms, like gravito-electromagnetics, right? And when you do, then you can scrap as well a good portion of Einstein general relativity, because you don't need to talk. You can connect to it that way. You can do tensor equations and, complex tensor equations and matrices, but you don't necessarily need to talk about it that way neither. You can do a mechanical equations, fluid dynamic equation, mechanical equations that on one hand gives you Maxwell's electromagnetics and on the other one gives you gravity. And when you do it right, which they're trying to get to, they're actually getting really close. When you do it right, all of a sudden you can scale it from the proton, from the Planck all the way to the universe, and it gives you the right answers with one formalism that actually kind of scrap both, QCD, QED, and a good portion of general relativity, because and connects with special relativity really nicely, so that like all of a sudden the whole thing is unified, and you can get all the right answers without doing like crazy mathematics or having unsolvable equations like third derivatives and stuff that like nobody can solve, right? Or that like you have to do Monte Carlo, like computations on you all of a sudden you get analytical solutions to all the different scales, and it's very, very, very powerful. It's very powerful, and the application to technology is very, very powerful. It's very exciting.
That's actually one of the questions we were exploring right as you came in was taking that concept. Okay, so there's a source. There's this energy that permeates all of space, and it's not a trivial amount of energy. It's a tremendous amount of energy, like really, really large amount of energy to free space. So one of the questions we were exploring is, so what do you think is the most important step for us to attain free energy vehicles and devices? And I was just pointing out, since I don't know the answer to that question at all, I was just pointing out that, well, the first step is that you've got to realize that there is this tremendous amount of energy that permeates all of the universe, that the free space has a very high energy density. So the energy's there, so that's the first step. You've got to come to that realization. And then as you're showing, the physics works out, and then you can start doing
then you got the roadmap.
The roadmap to get the technology.
Right, exactly. Because now you know how it works. So now you know what you got to do to reproduce it, to tap into it. That's like the critical part. That's why I've done experiments for 20 years, but at the same time, in parallel, I've been doing physics because the physics are required. But although, by deduction and some instinctive notion, you might get to devices that work. But if the physics are not with it, then it's really hard to get them into the world, because then people say it's not possible, all this stuff. But if you have the physics to demonstrate it, then the world can do a very strong effort to get there very quickly, because it's the straight roadmap. And, I was thinking about it more in your field, William, and Ines as well, because I know she's interested since she's doing all these consciousness experiments over there in Mexico. And, it makes me think of, if I want to translate it to my being, right? It makes me think like a person has like this ultimate source, right, of consciousness, like their super self, where they're wearing a cape and they're like superwoman, superman, like they're like ta ta ta, they're the master of all masters. They're all, like when a baby comes out, it comes out like that, right? Somewhat. But then, there's the there's a certain amount of screening, there's a certain amount of disorder, right? There's a certain amount of veils, you know that are like, so the access to this like ultimate source is like a very specific path, meaning there's very specific things you got to do to get past the screening and to get into that ultimate state, right? And if you know those techniques and if you know those tools, you can get there, right? But you have to make the effort. You have to, like you said, you first have to know that there's a superhero in you, right? You have to know it's there, because otherwise you're just in the screening, you're just in the noise, and it's like, okay, there's some energy, but it's a little bit decoherent and there's not that much, right? So but then when you know it's there, then you have to know the mechanics on how to like get past the screening. And so it's not even just in the technology, it's even in the way, like basically we're on the entropic side of the event horizon, where we're on the side in which things tend to go to decoherency and tends to go, like there's a lot of thermodynamics, like there's a lot of, diffusion of energy, right? And we have to get back to the source where actually it's negentropic on that side, right? It's negentropic. And on that side, that's the creative side that creates organization and coherency, both in our consciousness and in our technology.
It's so awesome that the same principles that can be applied. I've got an echo going. The same principles that can be applied for generating the technology, they apply nearly directly to personal growth. You can attain nearly the exact same principles to achieve that maximum coherent state, that superhero state in yourself. It's really, I think, a profound equivalence there. And I think something that is just as important as the technology and theoretical side of the understanding is how to apply it personally to bring yourself into that that superconducting, super efficient state of your being.
I guess that would also connect with the fact that if we understand it deeply enough, we could become the technology itself, like a consciousness technology. We could go directly to that if we reach that state, which would be amazing.
Absolutely. And I think that many masters across the ages have done that. And they were, I think, in some ways, precursor to the technology. I think you have to definitely do a certain amount of that before your society reach those levels of technology, because you got to come up with the math and the physics, right? Because you need that for the technology. So, it really is an amazing thing. It's like the universe is fail-safe. If a civilization doesn't reach, but it's on a time scale though. If a society doesn't reach that level of awareness on time, then they run out of resources, right? On their planet, there's overpopulation, all kinds of problems happen. And that society, or there's a meteorite that comes too close, or there's a sun flare or whatever, they get wiped out, recycled, the universe recycle all the atoms. They don't go anywhere. They just, disorganize and reorganize.
Just
right?
try again.
Yeah.
Try again later.
Exactly. So hopefully we make it on this cycle. I'd like that. I really don't want to do another one of these. Yeah, but I think we're close. I'm really excited. I'm really excited about the transformation that's arriving on the planet. At the same time, I really am concerned about the state of health of our society. And I'm really grateful for all the people that are dedicating their life, whether they know it or not, for the evolution of humanity. Because I think society is awakening to what has been shielded from them, screened from them, right? In many ways, not just their superhero phase inside of them, but in society, things have been screened from them, and it's becoming exposed. And I'm gonna leave it at that, because I could start raging, because I'm really upset about what they're doing to children right now, and under the auspices of keeping them safe, which in this case, and I'm not going to give details, I'm not going to say names or words that will get us banned, but in this case, something that is actually have zero impact on the young population. They're quite fine, and they certainly don't need to be given any, I'm just going to say it, in the general sense, any treatments are unnecessary for the young population, and most likely can have significant, which is coming out now, significant negative impact. So, significant. Okay, just saying. So I'm just gonna leave it at that. Otherwise, I'm gonna rage. And I do science, and so do you guys, William and Ines, and we're talking to Nobel Prize winner scientists. It's not in the realm of pseudoscience or anything like that. It's not a bunch of people, with political agenda. It's people doing good science and, taking the facts and coming to conclusions, right? So just saying.
Yeah, because because there's like also this like prejudice that all mainstream is all bad and they don't understand and all of that. But we have to understand that there's a huge misleading leadership. I mean, it's the leadership which we question. It's that part, because it's not organic. Where did it come from? Where did the religions came from? I mean, was that organic? Is that raised from the basis? I mean, for sure it was not the case. So that's the thing. We have been always misled, and it's like, okay, let's get over with that.
Yeah, exactly. Let's go to the source to everything. Yeah.
That image of the source remind me of the salmons going, against the flow of the river to go to the source of the river.
Right.
Let's be salmons.
Yeah. in turbulence. You end up at the source. That's a great video. It's a sad experiment because a fish dies, but you know, it's a really amazing thing. I think you can find it on YouTube. You know, if you put the object in the current of a river or a current like a laminar flow of water, and it produced turbulence, and then you take a freshly dead trout or fish, you know, and it's got to be supple still, right? It can't be that it was dead for 3 days, right? Or and frozen. So and you put it in it, the fish, first of all, it looks completely alive, right? But it will swim up the current to the object because of the turbulence, because of the spin that is in the laminar flow. And really, this is, you know, this is what we're doing. We're swimming up current and finding the source at all levels. So I'm, you know, everybody, we're in a really good place. I'm very encouraged. People have to be patient. You have to be patient with yourself. You have to be patient with the world. Everybody's learning, even the ones that you might think are not so great, right? They're as well stuck in gears that have been put in by others long before them and all this, you know. Everybody's stuck in these gears. It's just that now we're like finding which are the gears that are not working and that needs to be removed and or modified, and that's a really, really exciting thing. Really, really exciting. So should we take some questions?
Yeah, and so some of our top questions, they're really focusing on the technology application aspect of this research.
Yeah.
One of them from Barbara Andrew is discussing what was presented in Thrive 2. And they were asking, I wondered about the technology you discussed in the movie and that you were still waiting for some results from that. Then also we were still kind of in the middle of discussing with Christiana Altrian about what do you think is the most important step for us to attain free energy vehicles and devices? And I think that's a good one to approach it from and discuss it, because we can kind of lay a more general foundation for what needs to be done to get to utilizing this free energy that is the field.
Yeah. So there's two parts to the question. What was the first part?
Sorry. Yeah. So the first part was the technology that you discussed in Thrive 2.
All right. Yeah. So well, that wasn't my section, right? The technology in our laboratories. Well, a lot of things are moving forward. It's very exciting, and I would say that I know I've been saying this for a while, but it's on its way. The art crystal is, might look, trivial, but it really is a first step. But there is amazing technology that's following through, and we're in the middle of doing a lot of really important research. But as well, I've been concentrating mostly on theoretical sections because that needs to be finished, and that's taken a lot of my time. But there is advancements that are happening on the technological level that's really, really happening. And like, what is it gonna take? It's gonna take the world population to endorse the research efforts at the deepest level, and not like in their consciousness, but first of all, realizing, oh, there is a source, like you were saying earlier, oh, there is a source. And then, oh, how do we access it? Oh, well, we need the scientists to be well funded. We need good efforts. We need international efforts. We need, we can get there. I swear to you guys, I swear we can get there. Okay. Like, I wouldn't say this lightly. I really wouldn't. People, like it, first of all, I know because I've seen it, but I as well, I know because it's clearly happening everywhere in the universe. They're called atoms, they're called protons, they're called, right? So it's clearly happening. We just gotta like figure out the mechanics of it and then apply it. And we have now the theoretical tenets, but the economical, like the financial structures and the political structure have to endorse it and go, and I was thinking about that driving yesterday, and I was thinking, wow, how many years was I told that, and many others that, it would like UFOs were not real, and that like I was insane for thinking that such things existed. And if they did, they probably couldn't get to Earth because they were too far from Earth and all this stuff. And now, it's like all of a sudden, because a few documents leaked out of the Pentagon, and then eventually the Pentagon admitted to them, and then eventually the mainstream media picked up on it. Now it's like very serious. I mean, it's very, very serious. The 60 Minutes did a great episode on it, and it's being talked on 5 o'clock news, what's going on in our skies and all this. And the pilots that were there are clearly saying, from what they were doing, there is no way this is, some other country technology or ours or anything like that. So how many, so clearly these people figured it out, right? Whoever they are, clearly they figured it out. And clearly their civilization made it past this point, right? Because clearly they can get off the surface of their planet at ease, since they can come to ours and get off at ease. They don't need thousands of tons of fuel. They don't need like, to burn massive amount of stuff. And, so clearly it's doable. So let's just say just that, just that it's doable, right? Now, is it 1,000 years from now? I don't think so, right? Clearly what they figured, at least one thing they figured, is how gravity works and how to play with gravity, how to alter gravity so that it works. So open your mind, right? Like, just like it was hard for people to imagine when I used to start to talk about UFOs and extraterrestrial life. I remember in the 90s and the early 2000, it was like my audience would shut off, right? I could feel the energy change. It's like, it was too much, right? But now it's starting to, like, people are starting. So it's all of us that's gonna bring this into the world. But we have to ourselves be capable of going there. We have to see that in our future, and then we have to take actions to support that in our future, right? And, like I was reading stuff on the Chinese tokamaks this morning. You guys are on the research thread with us, so and it's just billions of dollars into hot fusion devices that have not produced 1 watt of usable energy, and it's like, meanwhile, so-called cold fusion's been there all along and so on. And of course, cold fusion is not necessarily the solution neither, but it was definitely showing, experimental studies have shown definite anomalies. They're hard to reproduce and they can be erratic and all this, but that's how science works, is you find this little, thing that doesn't work, it's like, and that doesn't fit your model, and then it might be a really small effect, but then you realize, oh wait, that's telling me something different about the universe, and then you exploit that, and then you realize, oh my god, it's a huge effect, right? It's so, but it's like you just poke through the screening to the source for a second, right? And then you fall back in the screening and you're like, how did I get back to it, right? But then eventually you figure out the mechanics on how that happens. But like, yeah, I mean, the main thing is that people band, we need a movement, to bring it forward, and we need the institution to make the efforts, and we need the scientists to write the papers and the physics, and that's why we're doing it. And so, I'm happy to announce that we have now 100,000 people taking the Unified Science course at the Resonance Science Foundation. We've crossed, I've been saying we're close to 100,000 for a few months. Now we're past 100,000. So it's really exciting. And so that is a pretty strong community, folks. And that's because people are interested, and people know there's got to be more. And when they read the course, they realize, wow, that kind of works. It's coherent. And they talk to their friends about it, and their friends take the course and they go, oh yeah, that's coherent, that works, and so on. And we're about, with the help of Ines and William and Marshall and Jamie and all this, but Ines did the bulk of the work. We're about to publish module 7. So that's going to treat all of the papers that were published since module 6 was written. So the electron paper, the vacuum catastrophe paper, and cosmology, and so on. And so that's going to like kind of fill in what you need for module 8 that's going to come out like a few months later, which going to explain everything that's in the new paper. And that's going to be so sweet. So sweet. That is going to be so sweet. I swear, it's going to make people cry. It's already made many scientists cry so far. Ines being one of them.
Yeah, it is.
And
oh my
and
God.
and our attorneys, and that are technical attorneys, and so on. And so it's really an amazing thing. And we're gonna make our best. It's a few hundred. Yeah, it's a few, like maybe, I don't know how many equations, but it's a lot of equations. But I'm gonna make some videos with Ines and Olivier and William and all this to explain all this in really clear terms, because everybody can understand it. It's really, really straightforward. It's really, really straightforward, and we started to explain it earlier on. So
yeah, it is amazing, because it's like everything was kind of there, but not exactly there. It was like confusing, and now it's so clear. It's so clear. It's like, oh my God. And it was just little piece, holographic solution, and so it's unbelievable.
Yeah. It's like a little poke into the
Yeah.
source, and then and then this piece, this piece, this piece, and then wow, it's all flowered.
Yes, I kind of had the same experience, because when talking at the beginning of this Q&A, it was the zero vegan effect. It was as well the same thing. No one paid attention to that, and it was like zero vegan, and it was, what's that? And so oh my god, and oh my god, and look at all these people behind, like saying, please pay attention to the fucking zero vegan.
The problem is that nobody can pronounce it.
I would say that's part of the problem. Yeah.
I'm not gonna even try. I'm just saying, I just call it the Z effect.
Because all the people and all these physicists that have been discussing with us in this subject about this topic, it was amazing, because they would all say, I cannot believe this. I cannot believe this. How can it be that this is something so important and no one talks about it? And there's even models that are so close to what you're doing, and it's like, no way.
Yeah. Well, because
that's part of a screening that is good on our side. This screening has helped us as well a little bit, I think.
Oh, absolutely. Yeah. I mean, luckily things happen at the right time. You just have to trust that things happen at the right time, when people are ready, and you don't know what's going to make people ready. Look at what happened in the last year and a half, which is horrendous in some ways, right? I mean, of course, I have, my heart is with all the people that suffered. My mom passed, from all this and all, and at the same time, the change it has produced in society is remarkable. Like the positives change, meaning the opening and the eyes opening that's happening right now, and in all walks of life, but as well in the scientific community, and that's what we got to keep our eyes on. We have to keep our eyes on this. Like, you have people at very high level of government and industry and so on, talking about things that you never thought would come out of their mouth, right? And it's like, wow, it really is transforming, and it's beautiful to see, and it's difficult at the same time. But what transformation, that's the whole thing with the screening, the random part, right? The Fermi noise and the Bose-Einstein thing is that, it has to break up somewhere so that it can reform, like in a higher state somewhere else, right? So you have to go through that part. You got to go through the phase transition, that feels like everything's falling apart and everything's difficult and all this. And don't think for a minute that you're separated from it, no matter where you go on the planet. Meaning you can go and like isolate yourself in a cave in the middle of the Himalayas, and maybe you won't be confronted every day with the 5 o'clock news and all the insanity or whatever, but you'll feel it. And you're, so many people these days say, I'm so depressed. I'm so, it's so hard for me to get out of bed. Like I feel it too. Like, oh my God, like I wake up some morning and I'm thinking, I'm like having the worst thoughts, and I'm thinking, where did that come from? Right? Because it's in the morphogenetic field. So you got to push through it these days. And it's really important. It's really important. Some of the people don't have the tools to be able to push through it. And It's horrifying, and it's dramatic. And some of these people are young population, like, they're like suffering because they don't see the whole purpose of the thing, right? They don't have the vision, and we can give that to them. It's there, but we have to get it out. And that's why it's so exciting that we're at 100,000 people. And now let's go for 200,000, let's go for 1 million, like, let's go. Let's go. And like with module 7, module 8, and especially with module 8, we're gonna get there, and we're gonna make this change all together. We're all going to make this change. And every single one of you guys listening today, and everyone that's taking the course, and everyone that's helping us and all this, like, every single one is important. Like, every single one, whether they know about us or not, any single person on the planet that's getting past the screening, right? At all levels, whether the screening to their own superhero or the screening of the confusion that's going on in society right now, and getting to the source and all this, every single one makes a huge difference. Huge difference.
There's a question here that maybe it's linked to what we have been saying. It's Simon K3 again. And it says, if gravity is a self-organizing vortex in the vacuum, as I learned from Nassim, if I got that correct, and he said, then if consciousness is the medium in which we experience reality or self-awareness that is natural arising within any sufficiently integrated feedback network, is or can our consciousness if affect gravity itself, organizing vortex, or does gravity operate in a different scale and not affected by consciousness?
That's a good question.
Yeah.
That's a good question. I would say that definitely consciousness can affect gravity. I think the effect might be really slight. So most of the time we don't measure it, we don't see it, we don't exactly, but it really is possible. Hi, Simon. Oh, yes.
There's my mic. C'est oui. J'ai pas pensé un peu, but
How
yeah,
you doing?
I'm
I
well.
love that. I remember you. I love that thing behind you. It's awesome.
Thank you. Yeah, it's a design for light and sound in a house design. Working with Native Americans that we spoke to, but my mic wasn't working well last time.
It looks like the Planck Fermi Bose-Einstein condensate type of thing. It's like
wow.
It looks like the Planck field organizing itself in larger and larger bubbles. But yeah, I mean, that's a good point. And is that true? Well, okay, so I'm gonna have to go heuristic on you because we don't have good measurements.
I see.
But definitely heuristically. So I wouldn't tell you this if I didn't experience it myself. So I'm just gonna like put that out, just so we're clear, right? I'm just gonna put that out. And I'm probably gonna get in trouble for it, but I'm just gonna put it out. There's many people around the world. Most of the time, people have spent a lot of time meditating, that have spent a lot of time contemplating and all this, that have reported experiences of levitation. There's definitely one famous dude from about 2,000 years ago that seemed to have been able to do that. But other than that guy, there was others, and I'm just gonna say it. I experienced that when I was in my van from like in the late years of the 90s. And one of those instances, and in both cases, I didn't do it on purpose, but one of those instances was witnessed by a third party, meaning I was not on the ground. I was sleeping, but I was just not on the ground. And so this I believe is possible, and it should be, a direct consequence. And with William Brown, we're in the middle of writing from the physics that we're writing on gravity and electromagnetism. We have direct means to connect directly to biology. We found the link, right? So we're in the middle of doing that. So eventually we should even have an equation that tells you how much data self-organizing vortex dynamic has to happen. What's the energy level that has to happen, like for instance in your mitochondria and into your ATP production and all this, for you to start literally producing gravitational effects. But I can't give you that equation right now, so it's heuristic in my answer. But I assure you, it comes from direct experience and from the physics I'm writing.
And that's the thing is that
directly related to what sorry, William. Go ahead.
I was just going to add that, within the biology, a lot of the ordering dynamics that are taking place is interaction of the macromolecules with that field. So, I mean, it's on a very small scale, right? But it is working with essentially the force of gravity. This is even evident in like the orchestrated objective reduction model of Roger Penrose and Stuart Hameroff. So like at an extremely small scale, albeit with billions and billions of reactions in the biological system, there are all these minute, you could almost think of them as quantum computations that are involving that gravitational field, essentially. And so, I could easily envision a case scenario where, all of those are summed together in a coherent way, and you have like a large scale change in the gravitational vortex. And you could see probably some pretty large macroscopic effects from that.
Right. But it's not practical. You see, that is the thing that that I've had to fight. So much I had to I had some difficulties with the mainstream scientific community at certain times. It's getting better. It's getting much better. We're past that. We're the mainstream now. But the on the other side, with the spiritual community, I've had a lot of that resistance as well, because the tendency is to say, but we don't need any technology. We just need us, right? Like we don't need no stinking technology. I used to get phone calls of people that were irate with me because they were saying, you have so much knowledge and you need to, you have a responsibility to guide people properly. And you're talking about technology, like we don't need more technology. We need people to understand better and all this. And it's like, it's true. But then I was saying, but you're telling me this on your cell phone while driving your car, right? Like, dude, it's like, yeah, of course, consciousness is the source of the technology because we build it, right? But the technology, right? It's, oh, great. Everybody goes into a cave for 100 years and learn to levitate. Great. Now what do? We levitate ourselves to work. If you levitate, if you levitate outside the atmosphere, now you can't breathe. So now you oh, you got a problem, right? So technology is just an extension of our level of awareness, of consciousness, is the beauty of this amazing universe, is that it can replicate, and it can replicate outside itself, meaning you can replicate your higher knowledge into something outside yourself that reproduce the same dynamics. It's just that so far we've replicated a level of awareness that's not so advanced, right? So the technology is a little bit clunky and a little bit destructive, right? But
Yeah.
but that's just one step in the evolution of a society, right? And then you can have
There's
technology.
one out of what you're saying and what I've learned from William in terms of the mitochondria moving at like 8,000 RPMs, and Einstein's quote of physical objects are not that are an extension of space. So it's and I guess, doesn't this have to do then relate to the ability to travel in spacecrafts that are warping gravity, that our consciousness is working with it? I mean, you're answering that I can't find the words to express what I'm saying, but it seems to be indirectly answering or speaking to that aspect, right? In terms of these crafts that when you move, everything is moving with gravity. So there's no, what do you call it, acceleration, or you don't feel that acceleration, which was another question I had last time that you sort of touched on earlier when you came on talking about gravitational mass versus inertial mass.
Right.
Those differences.
Right. So, I'm going to give you, and this is for humanity. So like, just humanity, please listen. The key to warping space-time. Okay. You ready for it?
Yes.
Okay. The key is that space-time is already warped in every point, everywhere. That's the source.
It's spinning.
Everything goes to singularity everywhere, right? It's already warped. It's connected. So it's already there. You just got to enter, the nature of it, right? I'm sorry, that's my phone. And it's not
FaceTime warping.
yeah. So you just have to connect with it, like into the network, and then it will, then you have access, right?
Mm-hmm.
And so let me shut off the phone.
Mm-hmm.
Oh, it shut off on its own. Okay, so this is really this is really important, meaning you only have to figure out the mechanics, right? So for instance, and by the way, on the mitochondria, from the later research we've done, we found that actually when it's in high energy state, mitochondria can spin at 60,000 RPM.
Wow.
Right?
Wow.
Yeah. So those are really good motors, and there's like millions of them, right? And so this is much more. So to understand is that you just got to get into the mouth of the vortex, meaning it's already warped, right? You just got to link into the network, and then you can go wherever you want. You can do whatever you want, but you got to link into the network. You can't be on the screening side of it, right? You got to be on the warp side of it. On the screening side of it, it doesn't appear like it's warped, right? Because you can't see it.
Yeah, look around. Yeah.
You're in the noise, right? But at the same time as you're in the noise, right? You're on a planet that's going thousands of miles per minute through space. That's in a solar system and going thousands of kilometers, miles per second in space. That's in a galaxy that's orbiting a huge black hole that's going like thousands and thousands, and then I keep adding that, you'll find that, you're already warped, right? You're already moving at the speed of light. you're moving at past the speed of light.
Yeah.
You're instantaneously everywhere. You're already warped because you're made of atoms that are singularities that are warping. And so basically, that's you, becoming aware of that is like, outside of technology, is like you finding your superhero. Oh, I'm warped to infinity already. That's you see what I mean?
Yes. Yes.
It's a good warp. It's not a bad warp, right? And
Sends me out. Yeah.
It's
Yeah,
not
yeah.
the spaghettification. It's not the spaghettification.
No, it's not the spaghettification. But you could think of the knowledge base of your superhero self as being strings, like spaghetti strings that connects everywhere.
That's spinning.
Yeah, like wormholes being like, strings that connects all the protons together that are like vortices, spinning in space, currents in space, or circulation, right? And so really that is the key. And then when you realize that, then you can manufacture the technology to link into the network, just like your brain is. Clearly your brain is, right? It's
Yeah.
tuned into the network, right? And it's quite capable of doing very remarkable non-linear information transfer. Like, for instance, like all the studies that were done at Stanford on remote viewing, So, although that might sound to some scientists that that's heuristic, it's not. That was tested, and from one end to the other, they were pulling students off the campus and getting them to remote view with no training, right? Like, this is a function that everybody has, right? And all of a sudden they could give you details of a place they've never been to, on the other side of the world, right? And so how did you get that information? Not in a linear way, right?
No.
Okay. So see, the information is accessible. That means you're already warped, right? You're already there. And when you make the device that logs on to that thing, well, then that device, is just like you can think of a place that you've never been to and figure out the information that's there. Well, you can think of a place and all of a sudden you're in that place.
Wow.
Right? Because the device is just following the coordinates of, the network, the warp network that you're accessing. All right? And that's really useful. It like eliminates, long commutes and to your local star system and so on.
And speeding tickets and anything like that.
Exactly. And it makes it so that all of a sudden you can have what they call right now a tic-tac event, right? Where you have an object that's like in one place, one moment, and then it's like 60 miles away within a second, and then and then it reappears, and so on. Like, this is, this is just using the natural structure of space as it is.
Yeah, thank you. Yeah, it really clarifies that a lot. When I explain and invite people to the foundation and the courses, one of the things, it may be a very naive question, but the difference between weight and mass, because mass is used a lot, and when they're listening to the lectures, is mass have to do, sorry to bore like anybody, the physics that are so simple, but mass has to do with, is it acceleration? I'm sorry, weight. Is that the difference? Because everything is measured in mass, the way you guys talk about it. And when I'm trying to get more people in the Residence Foundation, it's one of the things that come up, and I find myself sometimes I want some simple answer. I know I can Google it and they can Google it, but it's not the same as the way you guys, all of you explain it so simply.
Right. Well, you know, that's the thing. Don't worry if you're having a hard time with that, because even Einstein was sweating it.
Oh, okay.
It's not an answer. It's not an easy answer. People think, oh, you should be able to like define, you see, because that's why Einstein ended up doing an equivalence between, you know, acceleration and mass, you know, which is, you know, inertial mass and all this stuff. But inertia in physics is not defined. Like so mass is not defined. Right. So of course you're having a hard time explaining what mass is, because in standard physics, there's no explanation what mass is. We just know that it's equivalent to energy, right? So if you multiply the mass by the speed of light square, we know it gives you the right answer for the energy of the system, right? So we have that nice equation, but we don't know what mass is. We certainly don't know why c is c, right? Why the speed of light is the speed of light. So that means on the right side of the equation, we have no idea what's going on, right? We just know these values are there. And then we know that if we multiply these two values together, we get a thing that we call energy, which is the capacity to do work, right? It's able to do that amount of work. So that's nice, but it doesn't tell you anything about the things you just found an equivalence about. You don't know.
So is your paper going to answer that? Is your paper
absolutely, absolutely.
Oh,
at the most profound level. At the most profound level.
Wow.
We output the speed of light exactly. We can show exactly why the speed of light is the speed of light. We output mass directly from fundamental first tenet of mechanics. You know, straightforward. It's very straightforward. And I'm not going to tell you right now, because I'm going to show you the equation when I tell you, so that you understand clearly what I mean. But definitely, yeah.
Okay. All right.
You can think of it, it has to do with this elasticity and the surface tension of space-time, like of that fundamental fluid. You can imagine that there's a certain elasticity, if you'd like, viscosity to it. And when you calculate that, you find the speed of light. And so, you know, that really is really, and it's from first tenet, meaning it's not like, it's not an artifact of a bunch of free parameters, right? It's from the fundamental principles. So, So yes, of course you struggle when you try to explain math. And this was one of the biggest problem in relation to weight, because, you know, this was a big problem when I published a Schwarzschild proton, because they're saying he's insane. He's thinking that the proton is the mass of a mountain, right? And it's like, no, I didn't say such thing. I just said that there's an equivalence to the energy of the strong force, right? So clearly it can't be a coincidence that if you consider the energy of the strong force and you put it with the mass of the proton, you end up with exactly the Schwarzschild solution. That is, you end up with the solution of a black hole, exactly, not approximately, for that entity. I was just pointing out that cannot be a coincidence, so that, like, we don't understand mass very well, which is the fact. But you see, that's the thing, is that these are level of physics that most physicists don't necessarily understand. They don't think about it, right? They use mass in their equation constantly. They use energy in their equation. They don't think about, like, what is this I'm using, right? It's not, only a very few scientists, well, more now, because
I heard you speak about that. Yeah, and point that out, which is phenomenal. Is this what you were pointing to when you talk about Einstein having photographs of him riding a bicycle? And that is it touching on this aspect of weight, mass, inertia? Like, exactly. I was blown away when you said that in one of your one of these sessions a few months ago. Yeah.
Right. Because Einstein was trying to figure out what keeps a bicycle up.
It seems
Not
so simple,
obvious.
but it's not.
It's not. It's
Wow.
not. Gyroscopic effects are not obvious. Like even the Faraday motor is not obvious to explain. There's issues with the frame of reference. Why? How does the thing know to like, what is the frame of reference that the gyroscope is relating to, right? They call Mach's principle. There's, you know, it's complex, but basically there's a problem of frame of reference, which
Would
is
it have to do with
mostly ignored.
consciousness? Would it have to do with consciousness somehow? The energy of consciousness? In terms
Well,
of
that,
or staying down?
well, the problem is that when you say consciousness, it's like now you've added C to it, or we'll call it C sub O to the equation. So to differentiate it from the speed of light. So I'm going to call it C sub O, right?
Okay.
So if you add C sub O to the equation, now you have another value that you don't know where it came from, right?
Okay. Yeah, yeah, it complicates it actually.
Yeah, it's a free parameter. You say, oh, it's consciousness. Wow, okay, but what is that, right? You know, so you know the problem with the frame of reference, and most physicists, very, very good physicists, don't know this problem exists. This is why even Einstein couldn't push it through. He couldn't get people to understand, no, there's a problem of a frame of reference here, right? Like this is a huge issue. Like you know, for instance, there is effects like in which you have a Faraday motor. It's like a Faraday generator, right? These are like things that we invented hundreds of years ago, right? 100 and some years ago, and everybody thinks we understand these things. Of course, we understand magnetic motors. Of course, we understand, you know, Faraday motors, right? They're the most basic motors, right? You have an electrode, you have a cathode, and you know, you put a current, the things start going around. Okay, that's cool. Now write me a complete, not like a partial, like a complete fundamental first tenant explanation on how that works. No go. And people don't know that. They don't realize that because there's a frame of reference problem. For instance, you can take two magnets, stick them on a copper plate, right? On a copper disc, right? And then spin the whole thing together. There's no differential motion. Okay? You just spin the whole thing together. No differential motion. And all of a sudden, and then you put an electrode on the copper disc and an electrode on the shaft, right? That's holding the assembly. And you get current, significant amount of current. Where's the stator, right? What's the frame of reference? Like, how is this thing producing power? Like
Mitochondria.
you're just spinning.
I see.
Two magnets, you know, and a disc. Like, what the heck, right? So, you know, and this partial explanation, mathematics, that kind of does the job, but it kind of doesn't. You know, it really kind of doesn't. And that's not well understood. You know, there's another effect that's discovered more recently that, like, if you spin a magnet, right? You spin a magnet fairly fast, but not that fast, like with the Dremel, right? And you approach another magnet with it. No matter the orientation of the other magnet, you will capture it in a magnetic bubble, even if it's in repel or in attract. And you can lift the magnet and move it around the space, the magnet is captured. Okay. And so these things, they have to do with angular momentum and gyroscopic effect and all this. And so basically, to give you the key to the whole thing, is that when you're spinning the two magnets with the disc or whatever you're doing that has to do with spin, when you're doing it, there is a frame of reference, and that's the warpage of space-time. Like all frames in all universes are relative to what you're doing.
Mm.
You see, it's not an isolated system. It's never an isolated system. It's always in relationship to the whole.
Mm-hmm.
And what you're measuring as like a current or whatever you're measuring, like energy you're measuring, is just the relationship of that thing to the rest.
Mm.
You see?
Mm-hmm.
Depending of this relationship of that thing to the rest, it has a certain energy level that you're measuring locally.
Mm.
And you're thinking that it's only your local behavior that's producing that energy. No, it's non-local. It's never local. The local effect is always a result of the non-local relationships. You don't have a choice. The whole thing is warped. Does that make sense?
Yes, it does. Yeah, you brought everything for me and others, I'm sure, together in that sense. Yeah.
In the terms of consciousness, I could tell you the same thing in terms of consciousness. The non-local effect is the small voice in your head.
Mm.
Meaning that what you're doing locally is always in a frame of reference of a non-local observer, right?
Right.
Because, sometimes, often you see yourself doing something locally, but you're looking at it from an external perspective as an observer, thinking, wow, I'm really screwing up right now.
Yeah.
Or I'm, or yeah, who is that guy that's talking in the background? Right?
Yeah.
That's your non-local self. That's your superhero, right? Do you see what I mean?
Yes.
Same thing. And maybe that Einstein wasn't thinking that far or that deep when he was riding the bicycle, but he was definitely trying to figure out what the hell is keeping that bicycle up, because it's not obvious. So you think we have all that worked out, but it's not completely worked out.
Thank you. Thank you.
Mm-hmm. Mm-hmm. My pleasure.
Okay. I got this too.
Oh, wonderful.
Yeah.
You like it?
I love it. Yes. Very much.
Awesome. Yeah. You feel the energy of it, huh?
I do, and I charge the water. I feel the energy, and somebody spoke about it in terms of connectedness. Not so much. I think the first time I held it, I felt something, but I don't necessarily feel it. But I definitely get like energy, chills. There's a sense that way. And I charge the water every night, or almost every night, but yeah.
That's a good thing. That's a good thing, especially for this time in history.
Yes.
Stay healthy, strong, drink good water,
That's what I learned from all of you and William and Ness and the others. And I do my best to share that with others.
Awesome.
Yeah. Thank you.
Thank you so much. It's great to see you again.
Yes.
Thank you. Okay, I gotta get.
Oh, okay, yeah.
Go ahead.
I had someone asked about the Avogadro number. I just was wondering if this is something that could be talked about, but it's all right.
Yeah, well, this is your field. You want to talk about?
No, not me.
At least explain what the Avogadro number is.
Oh, okay. Well, let me remember that. It's the mole. Okay, so in chemistry, when you do chemical reactions, so it was found that this was happening in a certain proportions. So chemical reactions, when you read them, they happen in proportions. So you have the proportions of the reactants, and you get proportions of the products. And so the person that, so it was found, I don't remember the person who found it, well, Avogadro, but there was the person that established that it was happening in proportions in, so anyway, so the unit that you have to use in order to have these reactions written the way it does and explained as that is the mole. It's a unit of chemistry, and the mole is it's exactly the Avogadro number, which is the number of, let's say, atoms or molecules or particles that are involved in this
reaction.
in this reaction. So and it's a very large number. It's, I don't remember its order of magnitude. It's exponential, blah blah, very high number. 60.
6 to the 10 to the 23rd.
Yeah, I was gonna say William is probably gonna pull that out of his hat.
Okay. Yeah, and so, but that's from
William
the point
is
of
a
view of-
machine, man. He's a machine. It's unbelievable. So yeah,
yeah, that's what I can say about the Avogadro number. It's
right. So yeah, I mean, very quickly because I gotta go, but basically, you know, the concept is a result of measurements, right? And so it's correct because, I mean, we can find it. We actually outputted it from our equations.
that was my
Yeah. So it's just a scaling of the behavior of lower scales, right? So then it emerges at the higher scales at the chemistry level, right? And that's what we're finding actually as we're writing this paper, because in chemistry it's kind of loose, right? Chemistry, you have all kinds of things because they're only doing from experiments. So they don't really, excuse my language, they don't really give a shit if the physicists agree with it or not. You know, basically they're doing experiments and they say, well, this is the way it's working. So, you know, too bad if you don't like it. But like, you know, they have bond angle, like they have, you know, bonds between electrons. Well, electrons are the same charge. Why aren't they repelling? They shouldn't be bonding, and, you know, but they don't care. Like they just, this is how it works. So you guys figure it out, you know. Meanwhile, we're doing chemistry, so we don't care. So these guys are, you know, and I'm being, you know, cheeky, but I mean, it's not quite like that. It's just that there is a very fundamental scaling relationship, scaling factors in the universe that goes from the Planck to the universe, or from the sub-Planck to the multiverse, if you want, whichever scale you want to take. Anytime you're doing scaling, you need 3 different sets of the scales, right? To know where you are, you need the smaller scale and the higher scale. So, you know, you can go from the Planck to the universe and then you know where you are, or from, you know, the proton to the stars, and then you know where you are, you know, whatever you do. But when you do this scaling, then you figure out the scaling factor, which we did. And then when you apply it, then you see, oh yeah, you know, of course, in a reaction, there would be that many numbers of interaction that would occur. It comes right out of the equation. So it becomes like, it becomes understood. And then you understand things like, you know, like when you look at the forces in chemistry, then you understand things like, you know, a relationship between the strong force and gravity that start to explain as well, you know, the forces at the molecular level of chemistry as well, you know, which have to do with the bonds and with the van der Waals force and so on. All of a sudden, all that becomes unified. And then now you understand chemistry from the perspective of physics, which people that are more layman may think that's already done, but actually it's not. it's not done. So all of a sudden it's all part of the same mechanics, and that's what I have to say about that, because I gotta run. But thank you so much, you guys, to be patient with me. And I'm definitely gonna try to make myself more available. I want to do all kinds of stuff. I want to talk to you guys, and I appreciate all the amazing questions. And thank you so much, everybody, for helping us get to 100,000. And let's go for the stars. Let's go for the universe. Let's blow this world into the next dimension in a good way. It's no breaking down, but organizing into an amazing place. And thank you so much, William and Ines, for helping me today. I appreciate your time so much. And everybody at the Resonance Science Foundation and everybody at Taurus Tech. You know, an amazing team. Everybody at ARC, you know, an amazing team, an amazing moment in history with amazing people out there. Appreciate so much all of you and every one of you that's seeing through the screening and coming to the source of your amazing self. Much love to everybody. May the vacuum with you.